Okay, hello, ladies and gentlemen of trigonometry. This is Mr. Heron. Talking today, we're going to do a new unit, Unit 3. We're still going to be working off of the unit circle, so I'll have that handy, or you should be at least really familiar with it. What we're going to be talking about is just graphing sine and cosine. Kind of what does that look like? What pieces does that entail? And kind of how can I manipulate it? So that's kind of the big picture of what we're doing in 3.1 and 3.2. So I kind of put those two together. So things that kind of keep repeating can be modeled by sine and cosine functions. As we said at the very beginning of Unit 2, we called them a periodic function. So these are two examples of a periodic function. So you can see a normal heartbeat. So then you can see the sun and moon and how that impacts waves and wavelengths of the ocean are down here. So those are called periodic functions. That means they repeat the same cycles or roughly the same cycles over and over again. So what we can do is we can start to kind of look at how can I organize that? How can I manipulate that? How can I make it do what I want it to do? So if you look, one cycle just means I go through the entire thing and I return back to where I started. Okay, so that would be considered a cycle right there. So I start at one point and I go through the entire thing and I go back to where I started. So that would be considered a cycle. A period is how long it would take to go one cycle. Okay, so for this one up here, it's going to go from 0 to not quite 3 pi over 4. That would be considered that length. That would be considered the period length right there. All right. So the midline, or what some call the base, but it's really a midline, is your halfway point. You are halfway through the middle. You are halfway in between the top and bottom. So that's going to go right here. That's going to be considered your midline, that line right there. Then the last piece, the amplitude, if any of you guys are musicians, you'll get to know amplitude very well. Amplitude is how much I go up or down off of the midline to either a maximum or a minimum. Okay, so cycle, how often I go through. Period is how long that takes. Midline is kind of my average, kind of where everything kind of centers back to. And then amplitude is going to be how high or how small I get. Okay, so that's just kind of the basic pieces of a periodic function. All right, so what are we talking about? Well, we're talking about the sine function. So this is where your unit circle comes into play. So if you kindly remember, sine was my y value. Way back when we were talking about cosine and sine, we were talking about an ordered pair. Sine was my y value. Okay, cosine was my x value. Sine was my y value. Y values here measure vertical movements. Okay, so remember, y goes up and down. That hasn't changed since the first time you ever started graphing things. Okay, what that measures is my distance from the x-axis. How much do I go up? Okay, how far am I away from the x-axis? So if you kindly remember, this is at 1, 0. So at 0, I'm in here. At pi over 2, this is 0, 1. Okay, so I'm at 1. Pi over here would be negative 1, 0. So my sine value is back at 0. Down here, 3 pi over 2, I'm at 0, negative 1. So that makes negative 1. Then 2 pi, I'm back to 0. Okay, so all I did was kind of look around at my axes, x and y, and kind of the high point and the low point, and figure out what did I do. So what does this graph kind of start to look like? Well, at point 0, I'm at 0. At pi over 2, I'm at 1. Okay, in fact, let me expand this a little bit. Okay, I'm going to say that, this up here is 1, and then down here is negative 1. So each block is worth, a quarter. So by pi over 2, I'm up here at 1. By pi, I'm back here to 0. 3 pi over 2, I'm back to negative 1. And at 2 pi, I'm back to 0. So my graph ends up looking something like this. Okay, and it continues. So I can actually go backwards from it and kind of sketch that graph too. Okay, and this is a continuating graph. It keeps going like this forever and ever and ever. Okay, so I don't manipulate it. So your domain, what are my x values? Well, they go on forever. So I'm going to go from negative infinity to infinity included. Oops, sorry, inclusive. My range, where do I end up? Well, I can only go up to 1 and down to negative 1. So my range goes from negative 1 to 1. That's where I top out at. The period, how long does it take? We kind of talked about that up above. How long does that take to go one length? So that's going to take a period of 2 pi. My midline, where is my center? My midline here is going to be considered 0, or, y equals 0. And my amplitude is going to be 1, because I go 1 up and I go 1 down, okay? Some kids get confused and try telling me it's 2 because this distance, top to bottom, is 2. But no, you go amplitude from the midline. So you go 1 and negative 1. So my amplitude is going to be just 1. Okay, so for more important things to remember, though, most important thing to remember, though, is this is going to be 0, starts at 0, 0, 0, up to top, down to bottom. That's going to be kind of what the basic one looks like. All right. Cosine, if you kind of stick with the same idea, cosine, remember it goes cosine, sine. So this is going to be your left and right movements. This is going to be your horizontal or x value movements. So you want to put horizontal there. So now as you look around your unit circle, cosine, that's 1, 0. So at 0, I'm up at 1. Pi over 2, that's 0, 1. So I'm down over at 0. Over here at pi, that's negative 1, 0. Then down below, that's 0, negative 1. So all of my cosine values, all of my x values look like that. Okay, so now what does that start to look like as a graph? Well, at 0, just like the last graph, I'll make this 1, make this negative 1. I start up at 1. When I get to pi over 0, when I get to pi over 2, I'm at 0. At pi, I'm at negative 1. 3 pi over 2, I come back. 2 pi, I'm back up at 1, okay? This doesn't look like a V, okay? It ends up looking like this, okay? It's an arc, okay? And if I go back, it's going to look like that as well. So remember, this is 1, down here is negative 1, so this is 1, down here is negative 1. So again, my domain from negative infinity to infinity. My x is going to keep going. My range, I stop down at the bottom at negative 1, at the top of 1. How long does this take to go through? Well, how long does it take me? How far does it, how far is it around the circle? Well, it's going to be 2 pi. My midline is going to be y equals 0. That's what this line is, y equals 0. And my amplitude is once again going to be 1. Okay, so if you can remember at least the basics of what the graphs look like, it's going to be very helpful to you. Okay, so now they don't just stay like that because that would make things way too easy. All right, so these are the ways that you can manipulate those graphs. Okay, so sine is over here, cosine is over here. Sine's the one that, remember, that looks like this. Cosine is the one that looks like this. So what you're looking at are all the different ways you can manipulate that graph. Okay, and don't get intimidated. We're going to take this one piece at a time and kind of make things hopefully easy to deal with. Okay, so we're going to start off easy. We're going to start with A and D. Okay, so here's what I want you to think about for 2 seconds. So 2 seconds, if I think about the simple parent quadratic function known as y equals x squared. All right, and you can even throw this in your calculator. If you go y equals x squared, what happens if I put 2 in front of the x squared? What happens if I put x squared and then like plus 3? Well, what happens here? This grows 2 times faster, right? You know, if this is my quick graph, that means this gets steeper by a factor of 2. This moves the whole thing up 3. Okay, so just, you throw that in your calculator even if you want to want. But that's no different when you look over here. So what this does is A is going to change the amplitude. So normally our amplitude was up to 1, down to -1. So we go up to 1, down to -1. Start at 1, go down to -1, come back. If I throw a number in front of any of these, all that means is I'm going to increase my amplitude to that. Okay, that's it. For adding or subtracting at the end, or at the beginning, but just adding or subtracting on the outside of the whole function, means I'm going to move up or down by that many units. Okay, so this moves my whole thing up or down by, d units. So it's going to take my whole graph. So instead of my midline being at y equals 0, the plus d moves it up or down. All right, so I'm just focused on those two right now. The other one's coming to play here in a little bit. But so all I'm doing, I've got my basic functions. So let's kind of figure out what I'm doing here. So I've got this number on the outside, 3 sine of x. So sine of x is going to be the one that looks like this. So I go up, back down, and back. Okay? 3 says whatever sine is, multiply it by 3. So I want to take 3 times the sine of x. Okay, so sine of x, think back, it goes 1, 0, -1, 0, 1. I want to multiply everything by 3. Okay, so, sorry, I put the wrong ones in there. That's not, my bad, switch those. I put the wrong ones in there. If you were clever and caught it, good for you. My fault, I did not throw the right ones in there. So 3 times 0, 0. 3 times 1, 3. 0, -3, 0. Basically, I take whatever my values are and multiply them by 3, which, what's my transformation? What do I do? Well, this is called a vertical stretch by 3. Okay, what this is going to do is this is going to stretch it by 3. So my new amplitude is going to be 3. Okay, nothing else changes. The period stays 2 pi. The midline is still at 0. Amplitude is now 3. Okay, you put 3 out front, so the amplitude is now going to be 3. So what does this look like now? Sine function starts at 0. Except now, instead of going to at pi over 2 getting to 1, so this is what a regular pi function would look like. Ours is going to go all the way up to 3, back down to -3, and back up. This is the function that we want. This is our y equals 3 sine of x. Right there and right there. All right, so let's move on. So now we're switching gears. We're looking at cosine of x minus 2. Okay, so this minus 2 is away from the rest of the function. Okay, so what this is going to do is this is going to move the whole thing down 2. Okay, we call that just a whole shift. This would be considered a whole vertical shift minus 2. Okay, so it's a cosine 1. Cosine graphs look like this. So cosine 1, this is where it goes 0. This is, did it again, got it backwards. It's going to go 1. It is going to go 0, -1, 0, 1. So I'm taking the whole thing minus 2. So that's going to go 1 minus 2, which is going to be -1, -2, -3, -2, -1. All I did was take all these values and subtract 2. Okay, nothing else changes, all right? It's still a period of 2 pi. The midline now goes down 2 to -2. Okay, my amplitude does not change at all. All right, so all I'm doing is I'm either making the amplitude bigger or I'm shifting it up, shifting it down. So, but now my midline is down here. Take my entire graph and move it down 2. All right, so now what does my new function look like? Well, I start here at -1. When I get to pi over 2, I'm at 0, -1, 0, 1. And I'm going to continue it one cycle backwards, just so I get the full visual effect here. Oop. That's what it's going to look like right there. So again, the top one, I put the number, you see how the 3 is right in front of the sine of x? That's going to mess with your amplitude. The -2 at the end is going to be a full vertical shift. All right, so it's going to move the whole graph down 2. That's what I'm looking at right there. So now, I threw a negative in front. All right, well, let's see what that does. The answer is that's not going to do much, okay? The only thing that a negative does is basically flips everything over. So, it's a reflection. Basically, I'm going to multiply everything times the -1. So when you go negative sine of x, so we're back to a sine function. So it's going to go 0, 1, 0, -1, and then 0. Well, I'm going to multiply everything times a -1. So it's going to be 0, -1, 0, 1, 0. Okay, my period stays the same. My midline stays the same. All right, my amplitude stays the same. All that happens is that I take the entire thing and flip it over. So if I call that 1, call that -1. So I start at 0, but instead of going up towards 1, I'm going to go down to -1. Then back to 0, up to 1, and back. So it's going to be a mirror image of this one up here. So then coming back, kind of just mirror this coming back. It's going to look like that. So 3 things. You're either going to reflect it, you're going to move the whole thing, or you're going to mess with the amplitude. That's what we're looking at here. So now I put in 2 pieces here. Actually 3. Kind of do all 3 here. So this 3 is a vertical shift. Means I'm going to move the whole thing up 3. Okay, the -2 does 2 things. First off, it's negative, so it's going to be a reflection. And the 2 means that the amplitude is going to equal 2. Okay, so 3 things, all 3 things happening at once. So it's a cosine function. So remember, it's supposed to look like this, but it might be some manipulation on it. So I go 1, 0, -1, 0, 1. So now all of this, 3 minus 2 times the cosine of x. Well, 3 minus 2 times the number that's here. So 3 minus 2, 3 minus 2 times 1 is going to be 1. All right. 3 minus 2 times 0 is going to be 3. 3 minus 2 times -1 is going to be 3 plus 2, so that's going to be 5. 3, 1. Okay, what's the period? Still going to be 2. This is going to move the whole thing up 3. So my midline is now going to be at 3. My amplitude is going to be at 2, but it's also going to be flipped upside down. So my new midline up here, y equals 3. All right, my amplitude is 2. But remember, I go down first. So I swoop down, back to the middle, swoop back up and away. Kind of go back and sketch that. That's where I go. Here, 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 and here. That's what I'm looking at. So now what happens if I put the -1 at the end? The answer is not a whole lot changes. So 3 means my amplitude or my vertical stretch is going to be 3, and it's going to be a vertical shift of -1. So we're back to sine. Sine goes like so. So you're at 0, 1, 0, -1, 0. So all of this, 3 times sine of x minus 1, give me -1, 2, -1, -4, -1. Period is going to be 2 pi. My midline is now going to be at -1. My amplitude is now going to be 3. Okay, that's what this 3 does. The -1 sends the whole thing down. So y equals -1 is here. But now what's it look like? Well, I'm at -1. At pi over 2, I'm now at 2. At pi, I'm back to 0. 3 pi over 2, I'm down here to -4. And I'm back to here. So it's going to look like this. So then I'm going to kind of mirror that back. There we go. That's what it's going to look like right there. Okay, so 3 things that happen. This is going to mess with your amplitude or flip the whole thing over. This is going to move the whole graph up or down. So let's do a quick little matching game here. -3 cosine of x. Cosine of x, remember, looks like this. So a -3 means it's going to flip, and my new amplitude is going to be 3. And I'm thinking that the flip, it starts going down, it bottoms out at -3. I'm thinking that one's going to be C. Put the -3 out front. That means I'm going to take the whole thing and start down at -3, which I think is going to be B, because my midline is at -3. Number 3, 2 plus 1. So now my new one is 2. So now my new one is 2, and I move the whole thing up 1. So I'm thinking that could be right there, because y equals 1, and I have an amplitude of 2, which would mean D, -3 sine x. So I'm just going to look like that, but it's going to come down 3 and back up. I'm thinking that that one's going to be D. Okay, so a couple videos that you might want to partake in. Again, that we only did we didn't do all of the translations and variations you can do. All we did was one of them, but we're going to jump into the second one right now. Before we did our main 3, we did our amplitude, we did our midline, and we did the reflection as well. Okay, so we either flipped it, all right, or we moved the whole graph, or this one we stretched it, either bigger or smaller. So now we have 2 other pieces, a phase shift and a period. Okay, our phase shift, if you notice, the phase shift is x minus b on the inside. So it's inside parentheses, and it's very specific. This manipulates x, okay? And if you think back to graphing, x goes left and right. So this manipulates moving my whole graph left or right, okay? So period, everything we've had so far, the period is 2k, but there's nothing to say it has to stay like that, okay? So when I look at k, which is right after my function, all right, and right before the x, that is going to be my new period. Our default period is 2 pi, but if I need to shrink it down or extend it out, I'm going to take 2 pi and divide it by that. Okay, so this is going to take the whole thing and shift it left or right. This is either going to shrink it up or stretch it out, kind of the way an accordion looks like. When you pull it apart and push it back together, that's going to be kind of what that does. Okay, so we've got the three we talked about before. Amplitude, midline, stretch it vertically, stretch or move the whole thing up or down or flip it. Now we're saying, okay, how can I move it left and right? Or how can I mess with the period? So this is a complicated one, but it's not if you take it piece by piece. Okay, so let's start with this. What's the amplitude? The amplitude is the one that's out front. So right now my amplitude is not -2, but it's just going to be 2. The midline, do I add or subtract anything on the outside anywhere? The answer is no. So it's going to be 0. Okay, so you see how there's that 3 right there? So remember, that is my k. So I take 2 pi over that. So that is going to be my period. That means when I graph this thing, cosine looks like that. When I graph it, it's going to take the entire thing is only going to take from 2 pi to 3, 2 pi over 3, instead of the full 2 pi. The phase shift right here is going to be pi over 12, and it's going to be right. Okay? This is going to be the opposite of what you would think. See how it says x minus pi over 12? You actually want just the pi over 12. Okay? On the outside where you have like +3 or -4, that's going to be exactly what you think. It means it's either going to move up or it's going to move down. Okay? So we'll describe the transformation. Well, what all is going on here? All right, so describe the transformation. Well, it's going to be reflected because that's still a -2. All right, vertical stretch by 2. Or, amplitude is 2. Then you're going to have a shrink by 1/3. And where did I get 1/3? Well, 3 is k. So it's 2 pi over 3. Well, usually it's just 2 pi. So I divided it by 3. So that's why I shrink by 1/3. And then I'm going to take the whole thing and move it right, pi over 12. Okay, I'm not going to ask you to graph this because graphing this would be a little crazy. I don't want to graph this. I just want you to see this is an example of everything that could happen. All right, so let's start with this. All right, let's start with this. Let's start with something not too brain breaking. Okay, so I always like to think about, what's the graph roughly supposed to look like? It's supposed to look like this. Okay. So now, what is the amplitude? Well, do I have anything out front here? No, so my amplitude is going to be 1. What is the midline? Am I adding or subtracting anything on the outside? No, I'm not, so my midline is going to be at 0. What is the period? Is there a k in here? No. So technically, that's like 2 pi over 1, which is just 2 pi. Phase shift, am I adding or subtracting anything in here? No, I'm not, so there's none. So what am I doing? I'm sorry, back that up. I biffed something. That's 2 is going to be k. My fault. So you want 2k divided by 2. So my period is going to be just pi. That's my fault. I'm sorry, I biffed that one. Okay, I was mistaking it for putting a number out front. So describe the transformation. You're shrinking it by a factor of 2. Okay, so let's look at what we're dealing with here. So sine of x, at 0, you're at 0, 1, 0, -1, and then back at 0. So if I just graph that, okay, let's call this -1, or 1 and -1. So from 0 up to 2 pi, back down, back there. This is what regular sine looks like, okay? Takes a period, takes 2 pi to go through my whole cycle, all right? So basically what I'm going to do is, in the span of that, I'm going to run through the whole cycle. So I'm going to go all the way up, back, all the way down, back. Okay, so what I end up doing is, taking all of these divided by 2. So this becomes 0, pi over 4, pi over 2, 3 pi over 4, and pi. So in the span of pi, I go through my whole cycle. All right? So in the span of 2 pi, I've gone through 2 cycles. All right? Do you see that? I get real quick there. All right, so what happens when I start doing with this? Okay, so amplitude, do I do anything out front? Is there anything out front of cosine? No, so my amplitude is going to be 1. Midline, am I adding or subtracting anything? No, so that's going to be just 1. Period. Here's where I have to be very careful here, because it's usually 2 pi over k. Technically, something is happening to x, okay? Technically, what I'm multiplying that by is 1/4. So I'm taking 2 pi divided by 1/4. All right, so, fraction rules, multiply that out. That's going to take 8 pi. Phase shift, am I adding or subtracting anything inside of here? No, so there's none. So describe the transformation. I'm doing a horizontal stretch by 4. So I'm taking everything and really stretching this out by a factor of 4. So I'm going to go 1, 0, -1, 0, or positive 1, sorry. So cosine looks like this over the span of 2 pi. Except now I'm taking it over the span of 8 pi. Okay, so what does that mean? So that means that this is 2 pi, 4 pi, 6 pi, 8 pi. That's how long it's going to take to go. So cosine of x over 4, so that's going to be 0 over 4, which is just 0. This is going to be pi over 2 over 4, which is just going to be 2 pi. Pi over 4 is just going to be 4 pi, 6 pi, 8 pi. All right, so if I graph this, a typical cosine would look like this. God, I hope it'd be better than that. So, okay, that would be your typical cosine. All right, but now you got to think, okay, here's 4 pi, out here's 6 pi, out here's 8 pi. I just kind of extend this out. Now my graph looks like this. I start at 0. By the time I get to 2 pi, that's where I'm down to -1. 4 pi, I'm back to 0. 6 pi, I'm at positive 1. 8 pi, I'm back at 0. So I'm really stretching that out by a factor of 4. Okay, that's what I'm doing there. Okay, that's what your horizontal stretch looks like. All right. So now what am I doing here? We're not going to focus a whole lot on this. Amplitude, still 1, nothing out front of sine. Midline, I'm not adding or subtracting anything on the back or the front. So it's still, at 0. What is my, what's my period? I'm not multiplying by anything in here. So it's just 2 pi over 1, which is just 2 pi. The phase shift, this is where you're going to move it right by a factor of pi over 2. All right, so you're going to shift the whole thing right by a factor of pi over 2. So what does that mean? Okay, so we're dealing with sine. So sine is supposed to look like this. All right, so basically all that happens is your new starting point, instead of 0, is going to be at pi over 2. All right, so this is usually 0, 1, 0, negative 1, 0. Now I take my x and I subtract pi over 2. All right. So what does that do? I end up adding pi over 2 to everything. So this becomes pi over 2. This becomes pi. This becomes 3 pi over 2. This becomes 2 pi. This becomes 5 pi over 2. Basically, I take these and I add pi over 4 to them. Or pi over 2. Sorry, pi over 2. I add pi over 2 to all of those x's. All right, so like on 3-1 we were talking, that was your 4. So now that was manipulating your y. Now I'm manipulating your x. So let's if we call that 1, call that negative 1. Typical sine function. Start at 0, up here, back down to negative 1. That's your sine of x. Your sine of x minus pi over 2 is going to look like this. Now I'm going to start, here is my 0, here, back down. When I get to 2 pi, I'm at negative 1, and I've got to extend that out. So you see how it shifts the whole thing right. Okay. We will skip 6, but we'll look at 5. All right, so we've got this and this. Okay, so amplitude, nothing out front, so my amplitude is still 1. Midline, I'm not adding or subtracting, so that's still y equals 0. Period is 2 pi. In this case, k is 2, so I'm going to take 2 pi over 2. So my period is going to be pi. So this whole thing is going to be done by the time I get to pi. All right. What's my phase shift? You see how now it's additional? Now, you see how it's adding pi over 4? So now this means I'm going to shift it left pi over 4 units. So now what does this mean? This means I'm going to shrink, horizontal shrink, by 1/2. And then I'm going to go shift left by pi over 4. All right, so let's just think about it here. Cosine, and then what ends up happening here, okay? Cosine of x, x. So my x, usually it goes 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? And my cosine of x goes 1, 0, negative 1, 0, 1. How does all this change? Okay, my new function, well, think about what happens here. Everything happens in the span of pi. Okay, everything happens in the span of pi, but then I move it left. So now, here's kind of what happens. So let's just sketch regular cosine first. That's positive 1, that's negative 1. Here's regular pi. Boom. Here's regular cosine of that one. Sketched backwards, like that, okay? So now, 2 things I'm doing, and here's where things get fun. Horizontal shrink by 1/2 pi over 4. Okay, if I just did horizontal shrink by half, that means that I would run my entire thing in the span of pi. Okay, that is just the horizontal shrink by half. So now I want to move it pi over 4, which means I move it this way by 1 block, okay? Because like each square is pi over 4. So all I'm going to do is start here, and it's going to be right there. That's going to be my graph right there, okay? And I can keep going if I want to. All right, so basically from my new function here is going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. My new points become, oh wait, that's the ones I had before. What I want to do is cut everything divided by 2. So this becomes 0, pi over 4, pi over 2, 3 pi over 4, and pi. And my new points become 1, 0, negative 1, 0, 1. And then I'm going to shift everything back. So that's where I end up. All right. So I took my original, then I shrunk it by 1/2, and then I moved it left. Okay, and that's about as hard as that's going to get, moving it left and right. All right. 6 we'll skip because that looks really, really tough. All right, so let's take a look here. Determine the equation of the trig function given for the given graph. So let's take a look here. What do I notice? 1, I start at -2. My midline is y equals 0. Amplitude 2. I go up 2, down 2. Let's see. Over the course of 2 pi, I'm only halfway there. It takes 4 pi to go a whole cycle. Okay. Final piece, it's a reflection. What kind of graph is it? It is a cosine graph. All right, so let's take a look at what I got here. 2 pi over k somehow has got to equal 4 pi. So flipping those around, k is going to be 1/2. So k is going to be 1/2, but I want to reflect it, and I need to flip it. So k in this case is going to be -2. Okay. Oops, sorry, my bad. Amplitude is going to be 2, and it's going to be reflection. I know it's going to be cosine. So I'm going to put -2 cosine of x. This takes care of the reflection, and this takes care of the amplitude. So now if k is 1/2, I need to put that in there. So now it's times 1/2, or fully simplified, it's going to look like that. All right, so that's everything and anything that can happen with a sine and cosine function. Okay, let's look at the assignment. So this is 3-1. You can do all of those. All right, moving along. Yes, do number 7. I'll have you skip number 9. Just do 8 and 10. You can skip 9, 11, and 14. And I will have you skip number 11. 1. And you can skip number 14. Okay, so for 3. Okay, when we go to 3-2, I'll let you slide on 5. And then these I'm not asking you to graph, I'm just asking you to kind of figure out what's on. Then I'll let you slide on this one. And then this one and this one. Yeah, you can do the rest of those. All right, and if you play around a little bit on your calculator, you should be able to figure out how to graph them there too. Okay, that is all I got. I look forward to talking to you and helping you guys with these. And so you guys get good at graphing.